Okay, in this video we're going to be going through question 1 on a specific heat capacity work. Here are the questions that you should have got, and if you have not yet done them, then please do pause the video and try the questions out for yourselves. Once you've done that, unpause and let's see how you got on. So, first up is definition of specific heat capacity. This is one of those lovely marks in physics questions where you can just memorize it and we'll learn. So, you have no excuse but to learn this one. Specific heat capacity is the energy needed to heat 1 kilogram of a material by 1 degree centigrade. Okay, so, simple definition to learn. What it means is, well, some materials will take more energy than others to heat up. On to our next question. So, as we read, let's keep an eye out. 1.5 kilograms of water. Well, that's our mass. Okay, and kilograms matches kilograms within the equation or the definition, so we're sorted. Specific heat capacity of water is given as 4,180 joules in this question. And we're asked to calculate the energy needed to heat it from 15 to 100. Now the equation that you know, or we should know, is that the energy needed is the mass times the specific heat capacity times our change in temperature. Remember, sometimes you see a different signal there. This is not a temperature change. So, we've got a mass of 1.5 kilograms. That's good. Kilograms fine, no worries. Specific heat capacity, 4,180 joules per kilogram per degree. Yeah, that's all good for us. But our change in temperature, well, that's the difference between 100 and 15. So it's 100, take away 15, is 85 degrees C. So our units are all good, kilograms and degrees. That matches our equation. So the energy needed is the mass, 1.5 times 4,180 times 85. Put that into my calculator. Okay, so 1.5 times 4180 times 85 gives me an answer of 532,950. Energy is precious to us, joules. Moving onwards then, we get to power. Now, power, the same as when we did mechanics, it always links in that power is the energy per unit time. Now the energy we've got here from the previous one, 532,950 joules, that's good. Time, now in the question it's given it as 4 minutes. Now I know that we can calculate Usain Bolt's power, but we don't use minutes, okay, because Usain Bolt only runs for 9.5 seconds. We need seconds. 4 minutes multiplied by 60, okay, because, well, we're trying to get 60 seconds 4 times. So, set it up exactly the same. Okay, so 532,950 divided by brackets. 4 times 60 close brackets. And I don't want my answer as a fraction, so I press SD, and I get 2,220.2. 2,220. I'm just going to leave it at that. 3 significant figures is good. Watts is the unit of power. And the last question here was us to think around why the heating element at the bottom of the kettle. Well, this tells us to think about heating. And when we're heating up water. Water we can heat up using convection. Okay, and so what we get is convection occurs. I just made it into something resembling a sentence. So what happens when we heat water? So the water gains energy and spreads out. All the particles are moving faster. Spreads out. It becomes less dense and rises up. And once it's risen up, that transfers the energy to the top of the kettle. So having the element at the bottom works perfectly. Let me know how you got on with these questions.